morning, everyone.
Good morning, sir.
सर अभी स्क्रीन शेयर नहीं हुआ।
Yes, we have not started yet. The screen will be shared as soon as our director sir will join. Please be patient.
Okay, मैम।
Welcome, sir. Good morning.
Good morning.
Dr. Jagdeep Kaur, let us start.
Yes, sir. A very good morning to all of you. It gives me a great pleasure to welcome you all in the inauguration ceremony of the online STC on recent advances in data science and computational intelligence, organized by the Department of Computer Science and Engineering, Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. I wholeheartedly welcome the chief guest of the ceremony, Professor L.K. Avasthi, Director, NIT Jalandhar, convener of the STC and HOD of CSC Department, Professor A.L. Sangal, and all the participants. I welcome you all. Data science is an interdisciplinary field that uses scientific methods, process, algorithms like computational intelligence to extract knowledge and insight from the structured and unstructured data. This knowledge can be applied to a broad range of application domains. The motive of this STC is to learn about the latest advances in data science and its application in different fields like natural language processing, speech synthesis, data analytics, automobile sector, etc. The organizers of this STC hope that the participants will be enriched by the knowledge shared by the experts in this STC. I would like to call Professor A.L. Sangal, convener of this STC and HOD of the Computer Science Engineering Department, to say a few words about the STC. Over to you, sir.
Good morning to all of you. We are really blessed with the benign presence of our Honorable Director, Professor Lalit Kumar Awasthi. In spite of his busy schedule, he has taken out some time and presently he is at NIT Hamirpur. So he has joined us. We are grateful to you, sir, for blessing us on this very auspicious occasion. As far as the department is concerned, our Department of Computer Science and Engineering was started in the year 1990 with an intake of 40 students. And at that point of time, it was a regional engineering college, Jalandhar, which was a joint venture of Government of India and Punjab government. Lately, it was given the this is a national importance institution, a government public welfare institution, and especially this course, a self-sponsored, free of cost course has been arranged for all the students and faculty from other institutions as a social responsibility of the institution as a social welfare institution of Government of India. I congratulate the coordinators for perceiving this, not charging any student with any money, and those who are really wish to learn about the recent advances, the intelligence area, are really with us today, and there is no financial burden of any kind to the participants. This has happened only with the blessings of our Honorable Director, who has encouraged during pandemic time. Even this teaching learning process has not hampered at all. I hope in the next 5 days, the participants will be enlightened, will be exposed to the recent advances and experience which the speakers will be sharing with them will go a long way in igniting the young minds of the students and the researchers to decide their area of work in the days to come. I hope a lot has been said about the coordinator for the course, and let us see that how this course will be useful to you in reducing the labor-intensive problems without the human intervention in a system which we perceive with the advancement in the technology at present. With these words, once again, I thank the coordinators, and we are really blessed with the benign presence of our Honorable Director, for who is present to bless us on this very auspicious ceremony of inauguration of this summer short-term course on recent advances and computational intelligence. Thank you.
Thank you very much, sir, for your kind words. Now I would like to invite Professor L.K. Awasthi to say a few words. Over to you, sir.
Good morning and greetings from NIT Jalandhar. The head of department, Professor Amrit Lal Sangal ji, Dr. Jagdeep Kaur, Dr. Rajneesh Nani, the coordinator for this short-term course on recent advances in data science and computational intelligence. And I would congratulate both of them for taking this initiative of self-sponsored course, and this is very relevant area. This institute, NIT Jalandhar, came in 1987 as Regional Engineering College Jalandhar. We had a humble beginning of 100 odd students, and now institute has a total intake of BTech, MTech, PhD roughly somewhere around 1800 a year. And this institute has become Institute of National Importance by Act of Parliament. And the recent advances is that the faculty of the institute have performed excellent. They have almost more than 600 publications in a year, which is a record in the institute, and we have filed more than 50 patents. And we have also had around 100 such short-term courses in under TCube 3. And I know that how relevant this topic is, data science and its applications. The applications are a lot many. The data scientists are used to look into the fraud detection and risk detection. A lot many things are being done in healthcare. As you see, the present COVID-19 situation, there are many data scientists which are predicting the COVID spread in different countries, including India. And the second search has been under investigation. Then it is also, data scientists are also working on internet search. When we look for search, we go to Google. But there are so many search engines where you will find that data scientists have created that you should be able to get in 1 or 2 pages what you intend to search. Targeted advertisement is another area. So going to a store, getting your data, they are going to a website, getting your data from there through cookies or otherwise. Then, depending upon that, looking at your input credentials, targeted advertisements are given to you. In healthcare, we have the targeted medicines, how the targeted medicines can be given. Then there can be website recommendations to individuals who are using internet. Advanced image recognition. If you put a class photograph on internet, you may get some input because of the analysis of that clustered image into different people. It will be able to identify that you can tag these images which are already there on internet, or you can tag these people who are there on Facebook. Speech recognition is another area. You find so many assistants nowadays, and these assistants are through speech recognition connected to you. So you get your route navigated before you start. So these personal assistants, they are giving you all input. And airline route planning, from where the flight should start, where it should end, and how much delay is there, everything online. When people are there, they want that which place the flight has reached. So these all things are possible due to machine learning, artificial intelligence, and data scientists. Then another area which I can see is gaming. A lot of things have been done into gaming where data scientists are using the data, and they are looking into the possible solutions in a particular game. Similarly, we have augmented reality and many more. So there are so many applications. You can see tracking a vehicle, going into manless vehicle, driverless vehicle. So many things where we have a lot of data generated, and then this data is being used for predicting the path or predicting the things which can be only done with AI and data scientists. So I hope that this 5-day course will be good enough to give input to the participants into this latest area where there are a lot of jobs. We are following of the jobs in this particular area. I hope it will work as a bridging the gap between the already trained engineers, and by doing this augmentation of this course, they'll be good enough for any data scientist job. With this word, I congratulate Department of Computer Science, Professor Sangal, Jagdeep Kaur, Dr. Rajneesh Rani, Dr. Other faculty members for taking this initiative. Thank you. Jai Hind, Jai Bharat.
Thank you, sir. Thanks a lot. A graceful and a very good morning to our most valued guest, Worthy Director, Professor L.K. Awasthi, Head of Department, Professor A.L. Sangal, faculty members, dear participants, and all present here virtually in the inaugural function of online 5-day short-term course on recent advances in data science and computational intelligence. It is my privilege to propose a vote of thanks on this occasion. I, on behalf of the whole department, first of all, extend my most sincere thanks to the Almighty for choosing us to be the part of this learning process. I would like to propose hearty vote of thanks to our chief guest, Professor L.K. Awasthi, for gracing very first day of this short-term course and delivering the inaugural address. Thank you, sir, for your very interesting and thoughtful provoking address. I am sure that all the participants have taken note of your suggestions and will be discussing within their organization the action to be initiated at their level. I also thank our beloved Head of Department, Professor A.L. Sangal, for his guidance and moral support. I am happy to express a vote of thanks to our staff and research scholars that have made it possible to organize this short-term course through their motivation and dedication. This 5-day short-term course will be full of discussions, thoughtful learning, and research ideas. We have been fortunate to have some of the eminent persons from the academia and industry working in the area of data science and computational intelligence. I am sure that the participants must have been benefited by attending each and every talk of this short-term course. At the end, I would like to appreciate the participants for taking keen interest in this short-term course. Their presence will be really motivation for us to organize such time of short-term courses in the future also. Once again, thank you one and all present here. And with this, I end here and we will start our first technical session at exact 11 a.m. And the first talk will be of Professor Kamlesh Datta from NIT Hamirpur. Thank you one and all. So our first talk will be at 11 a.m. exact.
Thank you.
Yes, Kamlesh ma'am.
Hello, good morning everyone.
Yes ma'am. Should we start?
Let me see if I'm able to upload the presentation, then we'll start.
Okay. Thank you ma'am. Okay. So our first speaker, Dr. Kamlesh Datta from NIT Hamirpur is with us. So we will start within 2-3 minutes the first talk. And I will first introduce Dr. Kamlesh Datta. Dr. Kamlesh Datta is Associate Professor in the Department of Computer Science and Engineering at NIT Hamirpur. Her major research interests include artificial intelligence, natural language processing, network security, data science, etc. She has guided many PhD and MTech students in these fields, and at present, several students are working under her guidance. She has published more than 100 research papers in various reputed journals and conferences. Dr. Datta received Outstanding Award for her contribution to the Cisco Networking Academic Program. She is a very good speaker and today she will deliver her talk on data science introduction and application. So hope this talk will be very fruitful to you. Now I request ma'am to deliver her talk.
Dr. Rajneesh, please just wait. Let me see if I'm able to log in properly. Okay, then I'll
Okay,
start.
ma'am, we are here. You can.
Good morning, madam. You take your time. The participants have already logged in.
Yes, ma'am. Slides are visible. Kamlesh, ma'am.
Okay, am I audible now?
Yes, ma'am. You are audible and slides are properly visible.
Okay, okay. Good morning, everyone. Good morning, coordinators. Good morning, all the participants. Professor Sangar Sarji. Hello, Professor Sangar Sarji and Dr. Rajneesh Rani, Dr. I think Jagdeep, if I'm not wrong, Jagdeep Kaur, all
Yes,
the participants.
good morning, ma'am. Good morning, ma'am.
Okay, so it's indeed a pleasure to be part of your program, as I understand that this is one of the important topic of the time, which not is relevant just for the computer science people, but I think it has taken a step much forward by encompassing all the categories or all the branches and all the people from different streams. So this has raised the interest among different categories of people and experts. Reason being that nowadays this is the one which is touching our life in a big way. So therefore there is a huge interest in this area among people, among societies and in industry as well. So anything when something, any technology, if it finds some killer application, that is embraced by everyone, and you find that now people say that this is the one we should be actually going for, and this is the real thing at present. So I'm starting with my talk about the data science and its application. What are the myths, hype and reality? Because for some people they are very apprehensive whether it should be accepted as such or there should be some caution about it, and what is the outcome that it is giving, is it really reliable, and how are we going to really work around it. Secondly, the thing which is important for us is that some kind of conclusions that we are drawing, are they really relevant, or they are only some kind of a convictions, or some models which we are using in our data science methodologies, are they really relevant to our applications also. Also, when for the same data sets or same particular area, when the data are collected, if they are behaving differently, the people have some kind of a doubts. So we see that data science is something which is really becoming important in our real life, and it is having large number of real applications also. So the magic which it is having on the society and in the technology basically is that it works with the data. And in the present scenario, if you see, we have got a different sources of data that we are dealing with. And with this kind of a situation, naturally, how to understand the data and what should we infer from the data. So data is something which is becoming very, very important, and many of the domains which are participating now in our understanding this data are the data manipulation, visualization, statistical analysis, machine learning, and these are the techniques which we feel that people should be having, skills that people should be having if they really want to venture into data science domain. So it is a multidisciplinary domain, so therefore we see that we have got to we need the expertise in different areas. People should be good in mathematics, people have to be need to understand the statistics, programming, because if they want to develop good codes, then programming is essential in that case. Thereafter, how are we dealing with the data, what modeling techniques we are going to use, what visualization methodologies we are going to use, and not the least the domain knowledge, which is important because for that we are actually working for. So it actually involves extracting insight from vast amount of data, and we are using different scientific methods, and we are trying to discover hidden patterns from the raw data. So naturally, if it is so, then what the data is and how we are going to really understand it. The caution that the expert always put forward, that as a human being, we are really good at pattern detection, and even something is not clear, we are able to make out that what the pattern is. But at the same time, we find that it could be too understanding, okay, too much of the inference, whereas reality may be something totally different, as we can see here, that this is a picture from the Mars, and from the Mars something is seen, and we try to relate this pattern with the patterns which we understand as. So sometimes we may not be very correct also with the data handling also. So overall, the data science should be about the asking the correct questions, analyzing the raw data, modeling the data using various complex and efficient algorithms, visualizing them so that we have a better perspective. Of course, visualization is able to interpret the complete data in a better manner for us, but then even the visualizations techniques, they have got there some kind of do's and don'ts also. And thereafter, naturally, once you have dealt with the data, we want to use this understanding of the data in making the decisions, whatever results we have got. This has been possible because initially we didn't have, in early days, we didn't have much of the data, but now we are overwhelmed with a huge amount of data. But then the data that we have, okay, doesn't give us too much of the information. So there is a lack of scientific insight about the data. So we need to figure out what is all this about. Data storage techniques have improved a lot. the data that we are getting is unstructured as compared to the mathematical or numeric data that used to be dealt with in a previous decade. Now the availability of unstructured data is huge, so therefore, and that is useful for making the decisions, predictions, and pattern discovery. So therefore, we say that data science is important. According to Gartner report of 2021, there are several players who are really participating in contributing toward the data science field or AI field in a broad way. So there you can see that there are IBM is the leader, SCS is the leader, and so on. These are the leaders. Mathworks, that is the MATLAB and all. Then even some other players are there. Amazon, RapidMiner, Google is there, Microsoft. Some niche players are there which are actually working in the specific areas. And the new one is the Alteryx, which is considered to be a challenger as of today. Now, we see that what is the prediction that by 2024, 75% of the organization will be adopting AI and will be actually generating a lot also, and therefore they will be also putting a lot of investment in the analytic infrastructure. So if that is the case, naturally we see a huge opportunity for our experts who are comfortable or competent enough to handle the data. According to the hype cycle, which was given in 2019, if you see that there is a different domains in the business and intelligence, you can see are going to be there, and for them you can see that the range of existence which will there, the plateau will be reached in 2 years or 2 to 5 years or 5 to 10 years and even more than 10 years. But then business intelligence, for that you see that 5 to 10 years have been given for most of the cases, and or 2 to 5. So most of the problem domain, if you see, they will have their plateau level, or the means there will be a good achievements in these areas. If you see, not many are there. Peak of inflated expectation at this, you can see there the decision management is a high, augmented analytics is there, which now is no more there. Then data catalog doesn't figure here, analytic governance doesn't figure here, but many of the data related activities are mentioned in DBMS analytics, predictive analysis, outdoor location intelligence, and so on. So you can see that there will be some kind of a hype is there, and at the same time you can see that there is not much hype in other areas. As it is a multidisciplinary, it requires the skills in different competencies, ranging from your statistics, the maths is there, pattern recognition, neurocomputing, data mining, okay, databases is important to understand visualization. Machine learning, which is part of the domain of AI, is of course relevant here. So we can understand that varied skills are required. Okay, doesn't mean that only one skill is sufficient. If you need to have a different skill at the same time, one should be also able to communicate well enough. The amount of data which is created is huge. Okay, there is 2.5 quintals bytes of data is being generated every day, which leads to data explosion. So company which wants to sustain has to improve their businesses based on this data analytics easily. Okay, so this whole data has to be converted into some kind of a meaningful insight. As you can see that Google, Amazon, they are handling huge amount of data, and they are able to give a better customer experience also. Now in data science, what are the prerequisites? So some prerequisites, if you see, which are non-technical in nature, that you should have a curiosity. So data is given to you, it is huge data, so it is like finding a needle in a hay. So something if you want to find there relevant, then you should be having a curiosity and inquisitiveness to ask question that how this particular data is behaving, why it is behaving, what can be inferred from it, and so on. So why, what, how, these are the things which one should be having in their mind with respect to the data. Then critical thinking. So data scientists should find multiple new ways to solve the problem efficiently. You'll find that when you are going through this course, okay, this short-term course, during that you'll find that different models you will be learning, different techniques you'll be learning. be it modeling techniques or machine learning methodologies, you'll find that wide methodologies are available. But then you'll find also that their results are also different. Even after the parameter fine tuning, you'll find they are behaving differently. So alternative models, when you are considering also, you will see that different models, because they are mathematical models, so they naturally they may not have be able to infer exactly what actually may be happening. And then comes your communication skills. So whatever you have actually taken up, okay, you have inferred so far from the data analytics, okay, by performing various tasks. Data scientists should be able to communicate with the team and say that what he is supposed to do. These are the tips which we have already mentioned. So naturally here we'll see that machine learning is important, so one need to learn the machine learning algorithms. So in this course, I'm hopeful that you will be having lectures on the machine learning techniques to solve various problems. So no one technique is good or bad actually. So you will have to see that what works for your data set and what is your data set also. Mathematical modeling is also important for the calculations, prediction of the available data, and different methodologies are available. So if you will be using the tools, you will come across these models also. Statistics is required to understand the mean, median, standard deviations, etc. So this also give a good insight about the data for us. From the computer programming perspective, at least one language one should be conversant. This is important. Either one should be good enough in Python or in R. So these are things, or Spark. So it is all up to the expert. I hope that R and Python would be taken up during this course. So people should be able to do programming and do the coding in the R and have the insight here. Further, since you are dealing with a large amount of data, you need to be stored in a certain manner. So some databases, SQL or some other technique should also be there. Now, the hype that we see today is all because of the availability of huge amount of data and at the same time availability of the technology. So both have actually contributed to each other, because now we have a lot of unstructured data generated every day. Companies are generating data every day. Humans are generating data every day. So internet has led to the data explosion nowadays, and that has actually given the opportunity. And at the same time, technologies have also improved a lot. We have got a cloud computing environment. We have got a deep learning algorithms. So these deep learning platforms are allowing people to good hardware, good algorithms. So these all actually leading us to have the better insight into our unstructured data, and that results in a happening in the data science. Now, when we keep talking about the data science, this is a term which has been coined recently in this decade only, and all because of the availability of the data that we are actually doing. But if you see historically, the existence of this particular concept has been there. For example, in 1935 itself, Fisher, he proposed ANOVA, that is analysis of variance, where he gave various statistical models which allow you to find the differences among group means, associated procedures, and so on. So he actually carried out a lot of research statistically, and even he said that the correlation doesn't mean a causation. That means if there is some correlation, doesn't mean that there is a then that could be the cause of the happening. And he wrote very interesting paper about showing a link between and he opposed the aspect that there is a link between smoking and cancer. So by using statistics, he could show that there is hardly any link between smoking and cancer also. So that means when you have a data, you have to be very careful by giving the interpretation to it. Thereafter, even in 1939, quality control was where he talked about the statistical sampling. That means if you have got a huge population of a data, doesn't mean that you have to consider the huge all the population, but some sampling approaches have to be used so that whatever prediction you are making, you are able to have a good amount of reliability of the results. Now, in that case, if you see that the problem is that if you are considering a particular sample, that could be biased, and if it is there are biases, the reliability of the predictions could not be may not be acceptable. Then comes your in 1958 itself, Peter Lon. He proposed a term called a business intelligence system, where he started talking about the businesses and the decisions which are to be taken based on the text and data. So, term data science is not so new. Okay, it's a very old term. People have been doing the data analysis since ages, and based on the data, they are proposing their solutions. Then in 1977, okay, John Tuckey, he proposed the exploratory data analysis based on the which led to the development of S plus and R tools. So you can see that 1977 is the starting point of the R tool that we are using nowadays very popularly. And in 1989, again, if you see in 1958, business intelligence systems were proposed. Then in 1989, business intelligence term was popularized by Howard Resner, and in 1997 people started working on the machine learning algorithms, because that from that point of a time, if you see the neural networks, genetic algorithms and all, they became popular during that time. And then after comes the 1996 Google, okay, which has dealing with large amount of data. And so you can understand that the productivity which Google has raised, okay, the empiricism, analysis, simulation carried out by Google is huge. Okay, the contribution by Google in that sense is large. Then there are several other experts who are contributing, like Peter Norvig, data deluge, and so on. Okay, so we can see that there is evolution in terms of a data science historically, right from the previous decades. People have been dealing with the data and providing the solution. Now, as we see why it is becoming a good tool for understanding the problems that we are having in real life also. This is a scenario which has been taken from the paper, one of the paper, research paper, and if you see that this is data science can help in predicting the next pandemic using our data, big data. So given the information sources, we create our modeling, disease modeling, and there has to be a constant monitoring. Based on the monitoring, if something is really, there is a prediction warning that pandemic is going to happen or may not happen, okay, it may not happen, it may happen, and it may actually happen. So if it is actually happening, a modeling has to be done, corrective feedbacks have to be given, okay, and if the outbreak doesn't happen in such a certain situation, then the modeling fine-tuning has to be done. And once it takes place, the disease progression predictions have to be done, where it can happen, how it can happen, when it can happen. So you can understand that in the present time, that COVID-19, if you see that people are very much interested in understanding how the COVID-19 is going to affect our lives, how it is affecting our studies, education system, how the COVID-19 is affecting the environment, the air quality index in different locations globally, and even the places where even in India where it is, how it is affecting. So, and from the perspective of the management of the patients and all, this can be helpful in finding out how it will progress. So we need a predictive surveillance, we need a clinical surveillance, and you can see that a lot of data is being generated during these processes. So this is one of the paper, okay, which really shows how is it visible?
Yes, ma'am, it's visible.
Oh, okay. So this is one interesting paper which talks about the data analytics for the coronavirus, epidemic monitoring and control. So you can understand that data science is relevant in real life to a greater extent, okay? It talks about the deployment of AI techniques and data science methodologies. So what it says that we need to have like any disease, we need to have a macro view of symptoms which can be observed from people and their behavior before a confirmed case emerged and officially reported to authority. So this is a case where initially when there were no cases, you will not find anything happening. But after a certain amount of a time, when one particular case happens, and after that you will be able to figure out. But then how really you are going to figure out that it is going to happen? So if you see here that number of start to show symptoms of an unknown disease. Okay, so you will find that people are talking on the social media. So if on a social media you find that there is a surge of frequency of certain words, okay, then naturally that means there is some kind of a illness related problem happening in that particular area. So social media data that can be scrapped and then analyzed that really it is going to happen and or is happening. So this is one of the ways by which it is suggested that one should be always aware that the data which is being collected, okay, has to be collected from the data feed from CCTV, IoTs, mobile phone, GPS, voice, email, ATM. So that means the source of data can be anything, okay, and any anomaly detection, okay, which can happen. But then these anomalies which are known as an outlier has to be recognized as an abnormal. But all the abnormal event doesn't mean that there is a pandemic. So one has to figure out at what point this is really to be treated or considered as that there is an outbreak. Okay. So here if you see, okay, the correlation analysis is suggested that if there is some correlation with the data. Actually, it may not be directly, may not be able to figure out, but one has to establish through the data analytics that there is established a correlation analysis. For example, in a city, it is detected that there is a surge of tweets complaining about the discomfort. So some tweets are happening about the particular discomfort. There is a sale of symptom relief medicine from the pharmacy stores. So these signals can be picked up by the prediction system to analyze the anomaly and detect and correlate the analysis. Okay, so this is one of the ways that that means one has to collect the data and detect the anomalies among the activities in the cities which trigger to certain kind of things, and therefore they can be designed. Okay, the prediction systems could be designed. Now another thing is that okay, it has happened, but what to be done with the patients? In this case, naturally, because the severe illness means that more realistic estimation will be demanded and special resources would be required. Naturally, and those things you will not find in a normal, as is happening in nowadays, that there is a huge shortage of oxygen for the patients in the hospitals. Whereas if in reality, if it is checked, then the availability of oxygen could be there. But the problem is that they have not been made available, or they have not been arranged at the place where they are required. So this could be another thing. Okay. Now, when we are talking about the patient, okay, there could be several factors which could be there, and again all the factors may not be really reliable, or they may not really give you the correct interpretations. Okay, for example, if you take certain data like age, race, gender, okay, they will not be able to tell that there is a serious disease happening. So that means when you have large number of variable factors, you have to identify the right kind of variable factors which should be used to identify the problem, and you have to work on over a very limited number of patients in the beginning of the outbreak, and you have to figure out what is the thing that will be really helping. For example, here a surge in the hemoglobin level found in the body, muscle aching, and subtle fluctuation of the presence of enzyme alanine aminotransferase in the liver. These are considered to be the predictors together, and they are said to be giving the better accuracy for predicting the later stage illness known like the RDS. Okay. Now this is the one which says that which took many lives in the COVID-19 patients at the end. So these are that means instead of taking all the parameters which may be available in the data set, you have to figure out what are the relevant data sets which is going to be really contributing to your prediction approach. Okay. So this was said to be that they are giving the 80% accuracy over a small available sample set with 3 predictors. And if it is so, then if it is giving the correct prediction, naturally it will be a simpler problem. So naturally, initially when you have to give immediate answers, lightweight algorithms, lesser number of data sets, lesser number of features, but then they have to be correct one. So identifying the correct features, identifying the correct data set from where you are collecting, that is also important. This is the model which they have proposed, okay, flowchart search-based feature selection method, because we have to figure out what features are suitable. So features have to be identified, and then we have to identify what model we are going to use. Then that is another choice that we have to make. There are several algorithms which could be available, and you can use a different model, but again you will find that many of them will give the answer, whereas others may not be giving the answer. So some you will find, for example, here it is saying that random forest conducts a committee voting to vote for one that is more accurate than the other ones, and that's the final winner. So naturally one which is giving the better answer, and because there are several algorithms you can try out, you can use that one. Now another thing that is important here is we have to trends of disease spread have to be monitored also. That means if it is spreading, it has to be contained. Now if it has to be contained, then some additional control measures are to be applied. Now what are those control measures and how they will be effective? That is also important, and naturally models are required to be developed that so that it could be ensured, yes, it is going to happen successfully. Okay. So now, so one of the models which has been taken up for understanding that what should be the mechanism of carrying out the control, what can be done, okay, how we can flatten the curve, because for whenever an outbreak or pandemic takes place, our concern is that how we can flatten the curve. And if you're taking a lot of toll, okay, on the health of people and so on, and people are not recovering, then naturally it will be those strategies will not be good enough. So this is one of the model which has been developed by Stanford itself. Okay, this is a dashboard which shows how the spread has been taken place in different countries. So this can be this has been developed by using tableaus. If I show you here. So this is the COVID-19, this is a Tableau data, tableau.com, which is maintaining the data resources related to COVID-19. Different data resources are, and online visualization is possible here. So you can see it makes a summarized data, tell the story of the unique impact which is there. So with different countries, different occupations, how it is affecting in different races also, how it is affecting the black Africans, whites, Asian, and so on, by the occupation and so on. So different studies are being conducted by using the Tableau here. And naturally the objective that we are looking for is that how fast we can actually have the lowering of the or flattening of the curve. That is more important. So if that is our concern, different models are there, and they have used the model known as predicting the virus spread by SIR and SCR models. SIR model is a model comprising of 3 variables: susceptible, infected, and the recovered one. So this is the model which they have used, and they have actually shown that using that model, they have shown using a Tableau that how much how the death toll has risen in the US and European countries at the beginning of COVID-19. So this is the data that we can see that during the end of March in last year, okay, there is a steep rise here on the death. So they developed the model and demonstrated these concepts. Then they also showed the case of fatality rate for different countries and cure rate also for different countries. So this also gives us a good insight that how the data science could be useful in understanding the real problems of this one. This is another study simulations, okay, which shows that if isolation is applied, okay, the cases of a zero isolation, case of 80% isolation and 100% isolation, okay. So it shows the importance of isolation. If isolation is applied, then how fast the curve could be flattened, okay. So this is the size. So it takes the population and the isolation. So if we can increase or decrease the isolation level. So if we keep the isolation levels low, okay, almost very low, okay, and some population we take, and we want to figure out how the particular graph works. You can see here that there is a lot of infection happening. The number of healthy people is lower. Recovery rate is also happening. Okay, but in that case, the required hospital utilization is also becomes important. Okay, so you can see that it says that if there is a low isolation, 97.19% people are affected, and only 9.24% of people actually chose to self-isolate. So you can see that this is the graph which is there, whereas we want that the graph should be lower. Now if we use the same thing and we improve the isolation level, the model that they have developed according to that, okay, highest level of isolation if we are doing, then less amount of infection takes place. Your curve is also very, very flattened up, okay, less number of people are infected. That means we have to actually, it says that whenever there is a human interaction, the rate of infection will be higher. This is the highest level that we have put here. So if we keep here somewhere in between, because we want that economy should not also suffer, so somewhere in between we take. And in this case, if you see, though there is an isolation level, but the curve you can see here is better than if we are not using the isolation. Now this is a visualization of our problem. So naturally, for data science from the perspective, we see okay, so all these data analysis is based on the data made available by various sources. Okay, so you need, that means if you want to work on the data sets, okay, you need to figure out what are the good quality data sets available. So even if you want to find the good data, that has to be some reliable sources. It should have the data which is relevant, which can be used for prediction also. Now this is one of the data which is made available. It talks about the region last updated, latitude, longitude, confirmed deaths, and so on. So different data is available. So any data that you consider, you have to figure out what the data which you have taken, which type of data it is. If it is categorical data, or it is a numeric data, or it is geo data. So you have got a different types of data. Naturally, once you have collected the data, you can also work on this particular data sets, but then you have to figure out what type of questions you want to answer. For example, we want to flatten the curve. That means we want to figure out, we also want to have the data related to the control measures which could have been taken by the government or the people of that particular place. Now this is a study by ISC Bangalore. Okay, this is a study by the ISC Bangalore based on the partial differential equation based modeling for the COVID-19 infections. Okay, and this has been reported recently, and the model prediction was carried out in April 1, 2021. Okay, and So this is a scenario which is taking that how much zero factors have been taken. It takes a 10 times zero factor. That means these are surveys. Zero surveys are the survey methodologies approved for the cases of the epidemic situation. So how the surveys should be conducted, how the data set should be taken. So it's the current trends, wave 2, better, worse, 2 times zero factors it is considering. So this, if we take the case of say your Punjab, how it shows. Okay, so for Punjab, it shows current trends. Okay, wave 2. So it is a worse situation, better situation. So this is a graph. Data compared to the national trend based on the prediction. So it shows March 25. We are now at April 24. Okay. So it shows India trend is so it is not showing. Let's take one day. Okay, so this is what it is. The total India trend is 44.84 thousand. Okay, and on April 21, active data 43.9. Okay, and so on. So this is what it shows for recovered data. As you can see, is lower. Okay. And active cases, okay, it shows active cases also. Okay, this is around 81.4 thousand. Then it has got active data 46.56. So this is for this is a live data which is being shown. Okay. Now this is this model. Takes the 23 March 2020 partially data to tune the parameters of the data driven, and these are the results current as of April 01, 2021. So what it says that quarantine of active cases is very much required here to prevent the new infection, to contain the pandemic. So quarantine isolation is important here. Okay, the severity of the infection is taken into consideration while modeling the infectious rate functions also. So this is also have been considered. And summary is there that what in India, Karnataka, something are there. Okay, so you can see that data science, no doubt, has taken big place in our real life now to understand what policy should be made, what action should be taken to contain certain problems. Election is another interesting domain where data analytics being used, and you can remember. I hope you know Prashant Kishore, who is being hired by different political parties for framing the policies, and he works on the various conducts several polls and all are there, and they also work on various data available to them. And you can see that for the same problem, that is Bengal election predictions. Okay, if you see different organizations have predicted certain things. For example, certain organizations say that TMC is going to have more votes, others are saying that BJP is going to have more votes, and so on. But then they are in the prediction. Also, some of them have taken 2016 data also as a reference for making the error corrections also, whereas others have not taken. So this is another domain which you can see that exit polls are being conducted to predict the impact. But then we also know that these predictions may not be exactly true, or sometimes we find that particular organization has predicted and consistently their prediction become correct also. So why we are taking this case? Because here if you see that lot of noisy data is also there. So therefore sometimes whatever predictions are made, they may also fail. Here itself you can see that one are predicting that BJP is going to win, others are saying that TMC is going to have a comfortable win, and so on. So because all of them are using different variables, different parameter and different models for their analysis. Another thing that is interest to us is the search engines that are using. Okay, they are whatever searches we are making. Certain searches they are figuring at a higher point. Okay, higher level. This is another case of behavioral data sets where we use data related to various sites, and certain sites they become more important. Now they can be also highlighted by having the sponsored search also, and you'll find that particular companies they get more preference over the other ones. So you can understand that means data, and there is a money in this data. So whatever data they are using, okay, the data belongs to us, but then it is being used by the organization, and they are making a lot of revenue out of it. You can understand there are 97% of the company's revenue come from this kind of a marketing things. Okay. So they are using the competitions, okay, competition for models of the consumers takes place, and then they identify how they are going to use it. A lot of searches that we are being performed, so historical data that is being provided, okay, is resulting into a AdWord and AdSense also. Several other disciplines, you name it and you'll find that everywhere, wherever the data is created, that can be easily utilized. Netflix, people are watching a lot of online, on the online platform, a lot of films and all. So a lot of content is available. So watching those content requires that what makes certain things popular and so on. Again, data science comes into picture. Okay, fraud detections. Whenever someone is banking systems or the stock exchange systems, one has to ensure that the money which is being lended will be returned. So again, a lot of profile checking is to be done here. Wireless sensor data related to your smart homes, things and all. Twitter, Facebook, they are also generating a lot of product related information, which is again useful for the companies. Okay. Software log data helps in troubleshooting and all. Okay. In medicine also there is a huge amount of data which is being useful for them. Okay. Again, they are conducting research. Source, everywhere you find, you talk, and everywhere there is a data and data. So it is happening online, it is happening on the internet, it is happening in the scientific computing by whatever kind of text you are conducting. Okay, in any domain that you are working in, you are creating a data, and that data is becoming more important. Even the day-to-day activities which we are doing, okay, is generating a lot of data, and it is also generating information about our behavior, which is useful for the companies. So data is the new oil for companies. With respect to the data, what we see now, the raw data itself is voluminous, and it is changing very fast. That is a velocity. Third is the type. Variety of data that we are having is also too much. And quality. Whatever data we are getting, is it of a good quality or not? So data quality is also a big challenge. And with this data, we are expecting that it should be have a value, and one should be able to make certain decisions here. You can see here how the data volume is changing, how the fast the data is being made available. It could be a batch, and it could be in a real time, and real time speed also can understand is becoming too fast. Data variety, you can see that it is appearing in too many different, that means too much of a noise. If you want to work with this data, we have to first of all do the pre-processing. A lot of pre-processing is required in this case. Now, data that you can see that we have mentioned there, a lot of data is there. So when we want to store them, structure them, there are different ways by which you can actually have the data, store the data, because you want to work with the data. So a lot of data has to be there, but then what we want to do with the data. So again, a lot of things can be done, and we'll see what is to be. Okay, so objective is to turn the data into the product. That is one thing. And if you see the competitions, there are a lot of competitions are happening now online, and Kaggle is one of the repository which maintain a lot of data sets. Okay, so you'll find that regularly they keep organizing various competitions. So this is one of the competitions, the few competitions which I've just taken up. Okay, so this is a show US the data. Okay, this is the US related data. We started the competition having these many teams participating. Hacking the kidney, that means related the kidney image related data is there. So there again certain competitions are happening. This is a molecular translation, okay, which started a month ago, because I just picked it today only, so you can understand that these competitions are the live competitions and people can join them. So you need a lot of skills, as we have said, okay. Now, sort of things we need to have, okay, but then there is a similarity and there is a difference, slight difference also. From the database point of view, whatever data is there, it is precious. So they have the data which has got a, could be some proprietary nature and so on, belong to a particular organization. But when it comes to the data science, the data is made available freely. You will find that it is, you can have the data. So there is no problem in having that data, whereas databases maintained by certain organization, they are confidential in many cases. Also, volume, in case of a data science, it is massive, okay, and databases, when we talk about, it has got some kind of finite amount of a data, whereas in data science, everything is a data, okay, so lot of data is there. Now, in case of a database, we are more concerned with the consistency, error recoverability, auditability, prove that whatever procedures we are following, they are appropriate. Whereas in case of a data science, what we want to do is that the promptness, by the speed by which we are able to deliver our outcome, availability and query richness has to be there. In case of a data science, they are unstructured data, so therefore there is no hardly any structure is available. And the property that databases has to satisfy is atomicity, consistency, okay, integrity and all. Whereas in case of data science, it has to ensure the CAP property, that is consistency, availability and the partition tolerance. So it has to ensure these things. When we want to realize the data, handle the data, for databases, SQL is there, but for data sciences, since it is dealing with the unstructured data, no SQL is the one which is a choice, and there are others also. Okay. Now, business intelligence is another term which comes closer to the data science. Okay. Again, there are slight differences. Okay. Again, in business intelligence, you are dealing with the institutional data, whereas data science, again, as we said, it's totally unstructured. Method here, we are working with the historical data, whereas in case of a data science, we are trying to figure out more details here. Skills required for business intelligence is statistics and visualization, whereas for data sciences, we are also looking for the machine learning, statistical and visualization. In case of business intelligence, focus is on past and present data, whereas in case of data science, it also ensures the future predictions. So that is what. Next one is the machine learning, which is again an important area. Whereas in case of a machine learning, we talk about developing the new models. Okay, we say that some new models and how good the new model is. Whereas for data sciences, we are using the model and we are fine-tuning those hybridizations and also. So that is what data science does. In case of machine learning, we also prove the mathematical property of the model. Whereas in case of data science, we understand the empirical properties of the model, that whatever model we have used, how well it is understood by the, how empirical properties can be verified there. In case of machine learning, we improve, validate on a few relatively clean and small data sets. Whereas in case of data science, we handle massive data. So this is one of the important thing here, that there is a massive data. In case of machine learning, massive data limitation was there. And in machine learning, ultimately, mostly publishing paper is considered to be an achievement. Whereas in case of data science, it is the real applications which we see that should be tackled. So you can understand that data science is more on a real applications. These things we have discussed that are important. One should develop the skills, then only can do. What tools are available? R, Python, statistics, SAS, this is the data analysis tool. For data warehousing, you can use Hadoop, Amazons, and so on. For visualization, there are several tools, R, Jupyter, Tableau, okay. And for machine learning, again, there are several machine learning tools available too. So in machine learning algorithm, you need to understand what machine learning algorithms are there. So one should be aware of them. So they serve different purposes. Some are supervised, some are unsupervised. In case of supervised, you have some testing and training you are doing. There is a dependency of a variable. That means there are variables which are dependent on some independent variables. So based on that, you make the decision. So regression is one of the technique. Decision tree clustering is another approach. So these are different machine learning. These are some limited things I'm mentioning here. But then, for example, linear regression algorithm, if you want to use, which is a supervised learning, okay, and it is suitable for forecasting and prediction. And shows the linear relation between the input and output variables. And decision tree is another method, which is a supervised learning algorithm, can be used for classification as well as the regression problems. So this is another way of handling your problem. Okay. K-bean clustering. Okay, this is unsupervised learning algorithm, and it is used for the clustering problem. And you have got a set of items, and you have to, with certain features, you have to categorize them into certain groups. So K-mean clustering algorithm can be used. There are several other clustering algorithms, but this is one I'm just putting here, because in the course you will be studying all of them. And naturally, when we are working with the algorithms, some objective function has to be there, which is known as a square error function. Okay. So, using machine learning, what are the possible questions? Because what we said that inquisitiveness is important. So, the questions which could be there, is this A or B? That means it is we want to differentiate between two things. So, differentiating between the two things, and we know that what is A and what is B. So, there are A and B are the categorization. So, we say that we want to use now here the classification algorithm, if we know that A and B are the two categories. Now another is that we have got a data and something different thing is happening. For example, in your intrusion detection, if there is a attack, that is an anomalous behavior. So if that has to be detected, then we want to find out what is a normal thing and what is the abnormal thing. So if our query is that is it different from the existing scenario, then anomaly detection algorithms have to be taken into account. Questions like how much or how many, okay, for that regression algorithms could be more suitable. That means something prior data is available and you want to do the extrapolation. How is this organized? So to see the behavior, because we don't know how they are relating to each other. So clustering algorithms will be suitable there, because no initial prior differentiation is there. So we want to figure out that based on the data, how they are grouping into. Okay, what should I do next? So for that, reinforcement learning could be the things. What steps are to be taken? That means whole data science life cycle looks like comprises of discovery first of all. That means we need to have a question. What we want to look for? Okay, what is the question queries that we want to answer? So and based on that only you are actually going to work on your data, because data may have a lot of things, but for your query certain amount of data is suitable, other may not be. So you have to actually first of all identify what is that is formulation of a problem is important. So one has to understand the problem, formulate the problem properly, and after that you will be able to determine that in order to answer that particular problem, give answer to that problem, you have to what data or what are things that what are your requirements and what is your hypothesis that you are going to work with. Next, whatever data you have got, directly it may not be usable. So you have to work with the data and you have to do the data cleaning, you will have to do the data reduction, there could be data integration, there could be data transformation. So there could be different tasks, maybe all of them you are performing or you are performing some of them. Not necessarily that everything has to be performed, but these are the things that you have to prepare, the pre-processing tasks that we call. So they have to be prepared. Thereafter, you have to figure out what is the model. Model planning has to be determined. Different methods are there. So you have to figure out what is the how you are going to establish the relationship between the input variables that you have. So you have to do some exploratory data analytics using various statistical formulas and the visualization tool to understand the relationship between the variables, and from that you are able to you need to find out. So different tools again are there. Then you have to develop the model, and for the data set that you have to create that data set as a training and testing purpose, and then you have to apply different models, whether you want to find the association, whether you want to do the classification or the clustering. So again, there are several tools available here. And once you have done, you have to do the proper documentation so that it will be usable, and then communicate your findings with your team. Different ways, data acquisition is important, as we have said, because data which you are collecting, okay, that is lying here and there everywhere. So it has to be collected. So for that you will need certain APIs. You have to scrap the data from the internet. So for that, appropriate APIs have to be utilized. And then you have to convert the data into binary data into the useful data. Do all these things that is necessary. And data could be important. So you need to save it in a proper format. Do the pre-processing, it is important. Pre-processing at times will require that certain data may not be present also, some values are missing. So you need to frame the policy or strategy, what you are going to do with the data or the elements where the data is missing. Either you are removing them or you are extrapolating them with certain values, you are defining certain values, you are entering certain values, so that again it does not affect the data quality. That is, you have to be sure. So this is thing which overall you have to do have the understanding of the problem, have the hypothesis built up, do the collection, verify the data, clean the data, do the exploratory analysis, and so on. Now, talking about data science, okay, several expectations are there, several apprehensions are there. So several myths associated with it is that it can be handled only by the statistics and mathematics experts. No, it is a cross-disciplinary field. The basic aspect of curiosity to learn the new things makes a better scientist. So something who has the ability to understand the problem is more important. So just arbitrary way, if you're handling the data, doesn't make sense. Okay, you can come out with any kind of a results with that. Then data science only fits best for large organization with large resources. So it is apprehension that only the people with a large amount of resources they can have data science. No, it is not so. There are several tools available. Open source tools are available that can be used. Different data sets are available. Even they are freely available, open source. So you can use them also. So initially, even the small companies, small organization could be benefited because any organization has the data. Okay, all the organizations, they have certain amount of data. So if they can utilize their own data for their own benefit, it is not so difficult. Okay? It is difficult to adopt because it's complicated. Again, it's not so. You can start with a small problem, small queries. Try to get the answer for those small queries, then try to work with the other models, other strategies, and once you are able to get small results, you can go for a higher level results also. More accurate results only if you possess more data. Again, there are problems you will find that in real life that where a very small amount of data is available and a large set of data is not readily available. So for that kind of a problem, there are models or there are techniques available which can work on the small amount of a data also. Also, there are techniques where you can augment the data also. You can create the synthetic data and that can also be used there. So it's not that only you can have the accurate result with a large amount of data, but if you have a large amount of data at times, there could be biases also. Okay? Now, acquiring an expertise in the data science tool is enough. That means learning one tool. I know Python, I know Spark, I know R tool. So now I have the expertise of data science. It's not so. You need to have the understanding of the domain problems also, how the problems are taken and what are the methodologies adopted in those cases, as we have seen that COVID-19 pandemic there, and how the sample data are considered, how the models are to be considered there would be specific for the domain also. So specific domain knowledge is important. Okay, then you can be using the correct kind of a tool, because there are large number of tools. So understanding which tool is correct for a particular domain, you need to have the understanding of the domain also. So for not just a tool, but one has to understand the business domain also. Data science is all about building models. Again, this is another misconception that you have to build the models. It's not so. Just developing model is not sufficient. If you see the data comes in a different ways. It will have a lot of errors. It will have a lot of noise. So you have to first of all work with the data, and that data has to be first of all ensured to be correct. Otherwise, your all models will give you incorrect results also. Data science will soon be substituted by artificial intelligence. It's again because there is a lot of human intervention. If you see here in data science, though there are new models are being developed, automation is happening, but still human intervention will always be required, because essentially what is to be answered, okay, that queries are posed generally by the humans. So they try to first of all deal with the data. So the cleaning of the data, preparation of the data, this is very repetitive and still very difficult task. Still AI has not been very helpful in this case. Okay, data science is just a hype, it won't last long. Now this is again an issue which that means if you prepare yourself now and if you're going to and spend 2, 3, 4 years after that, you won't be good enough for the industry. It's not the case, because industry is growing very fast and they are generating huge data, and they will keep on generating new data, and new situations will arise. As you can see that whatever predictions were made in 2019 with respect to 2020, the situation COVID has actually totally disturbed everything. So you can understand that new studies have to be conducted, and the fresh cases have to be taken. So data science will always allow you to understand the businesses, the drawing hidden pattern, and new solution can be developed. So it is not a hype, it is going to be there, because businesses are going to be there for a very long, okay, in the real world. So the need for having the data scientists will be there. Certain statistical methods which I am listing here currently can be using, because a lot of data is coming from the social media and so on, from the internet, from the IoTs and all. So the different different methods could be employed here. And similarly, different tools are available, languages are available, different libraries are available, data engineering is there, and visualization. So visualization is another important thing that help you to understand the nature of your things, okay? And after you have developed the tool, they also have to be, the user feedback is also required. What is not data science? It's not academic research. It is basically the application, okay? It does not go for a major overhaul. That means you are going to make changes in the industry. No, it is not so. It is just understanding the scenarios and giving the suggestion or decisions for better things, okay? And it is not collecting the new data. It is working on the existing data only, whatever data is there. So you can understand this is the new data future, okay, helping organization to address customers' need in a better way and so on. Another thing that is important here is to how different concepts in data science are related. First is theories, then we talk about the models, then intuition, causality, prediction, and correlation. Now theories are statements of how the world should be, okay, and models are implementations of the theory. and the result of running the model lead to the intuition. So this gives, that means based on some theories are there. Of course, by the advent of data science, those theories will be tested. The models which are implementing those theories are also tested, and we are trying to have a model and generating the identifying the intuition that what is the world actually looks like, what this data is all about. Now, with respect to predictions that we are talking about, okay, so once we have established the intuition for the results of the model, it remains to be seen whether the relationship we observe are causal, predictive, or merely correlation. This is important with respect to the data that we are working with, because whenever you are working with the data, you will find that you will be using certain statistical methods where you will try to figure out what is the correlation. Is there some causal relation, as Fisher tried to deride the relation between smoking and cancer. So this is the thing that are we really talking about the causal? Are we able to establish the cause correctly through the correlations? Are we able to do the prediction correctly? So these things, that means whatever theories we have, okay, they also gets tested through the data science. Now, causality is a property which is very, very difficult, and this is important for us. As you can see in the COVID-19, we have been trying to establish the causation of the COVID-19. Okay. Also, in many cases, there is a correlation, but possibility is that we are not able to do any prediction on causality also. For example, in some of the earlier studies, the Walmart, okay, found that there was the purchases of beers and diapers were highly correlated. So, as such, they may not find any correlation, but then they found that through the analytics, they found that there was a correlation, and that means the supermarket should place them together. That is something correlation, but as such, if you see, there is no causality between them. So that is another thing that one has to look into. Another thing that people are worried about is that relations that is there, okay, relationships are multifaceted correlations among people. So if you see the Facebook, Twitter and all, these platforms are actually identifying the human relationship using graph theory, and using these graph theory concepts and all, they are trying to understand the people, how they are related to each other, what are the goals from profiting from them, and that is what they do. So they will identify your relations with others, and how much they can be profited from you and your own relations. Okay, so this is another thing that which is there, which is being done, and they are trying to understand the human behavior by using the data science approaches. Okay. So several things, this is an interesting thing that even people are not sharing certain things. Can we know if a woman is pregnant even if she doesn't want us to know? Okay, so many people who do not, some people say that, okay, we have a very less digital profile, so so we are not susceptible to these things. Even that is not true, because then you fall in that category of people who are lesser. So if there are less number of people in that category, the organization tend to explore more about this kind of people. So whether you try to be having a digital presence or not, you are still a data for them. Okay, in all ways, whether you are there or not, you are a data for those organizations, and they are always trying to tag. And now this is on a lighter side, that what data science can lead to in your real life. So this is a Google pizza joke where a person ordered the pizza, then he said that, so it's a wrong number. No sir, Google bought it. Okay, take my order please. So they give the order, and according to our caller data sheet, in last 12 times he ordered pizza with cheese and so and so. So he said, okay, then they suggest the different thing. So he said, okay, I hate vegetables. So he is informed that your cholesterol is not good. Then he's, how do you know? Do you cross the number of your fixed line with your name through the subscriber guide? and the result of your blood test for the last 7 years. So he said, okay, I don't want visa. I've already taken medicine. So then they say, no, you have not taken medicine. Okay. Because from your commercial database 4 months ago, you only purchased a box with 30 cholesterol tablets. So he said that I bought it from another one. He said, no, you didn't buy. So he said, I paid the cash. Then they said, you have not withdrawn the money, and so on. So you can understand that the data science in your real life could be really knowing a lot about you, more than you know about yourself. So as a data scientist, this is one of the finest job in this century. There is a big place for them because every organization needs these people, and they find the stories, they extract the knowledge, and they are not the reporters. So with this, I think I've shared everything. So this I've already shared. Okay. There is another interesting, you can read this paper also, Intuition, Not Prediction, that COVID crisis makes the data-driven projections inaccurate as the past provides zero guidance for the future. So you can understand, now they don't talk about the term prediction, they say it is an intuition and not this thing. There is another interesting paper, and similar paper will be there, you will find, about the analysis and prediction of air quality index in India during pre and post-COVID pandemic using machine learning algorithm. So you can see that it could be used in different locations, different positions also, and different applications are there. You name the application and it is there. So with this, I stop here, and I expect that future lectures will be more in depth, giving insight about the data science approaches, how the data is to be handled, how data is to be pre-processed, different approaches about that, how sampling is to be done, different ways of sampling, different machine learning algorithms, different statistical measures which are suitable, and the domain specific problems where you can understand that what kind of methods have to be there. PPT I'll share. I don't think you will have better PPTs in rest of the course. I think this was just an introductory, but I'll share it. Yes, so any question people would like to ask?
Yes, any query from any participant? Okay.
No, ma'am.
Yes, Yash.
No queries.
Okay. Thank you, Kamlesh ma'am.
Thank you.
Thank you,
I wish all the participants good time, because please make best use of this particular course. Data science, even if you are not a computer science person, or if you are not in a domain specific having knowledge, please do participate actively. This course is not about listening. This will be more about your own participation. How many months will it? I think there is something. How many months will it take? Well, if you are see, basic concepts have to be there. Your maths should be good enough, fair enough to understand the things. If you don't have a maths understanding, then it will be difficult. Do we get any assistance? I think in the in this particular course, they will be providing assistance on the projects. They will be sharing certain projects during this course. So please carry out the project. Then only you'll understand. Take one project, one problem. For example, the COVID-19 problem itself. You will be comfortable with it. Best platform. There are several platforms are there. You can see our tool is one of the very good. But there, I think, several platforms are giving several good tutorials. Start with the R tool. The libraries are very rich for data sciences. Yes, I think.
Okay, thank you, ma'am. Thank you, Kamlesh, ma'am, for such an elaborative talk on data science. Ma'am, you have tried to clearly explain all the concepts by taking real world problems and research ideas. Your talk will really be beneficial to all the participants. Once again, thank you, ma'am, for accepting our invitation and being a part of this online self sponsored short term course. Thank you, ma'am.
Thank you all, thank you organizer, thank you Dr. Rajneesh for inviting me. It has been always a pleasure to interact with the students.
Yeah, ma'am. We know you are always there and always a part of our every STC. Yeah. Thank you, ma'am, once
Thank you,
again
have a
for
good day.
accepting our invitation
I'll share
every
my
time.
PPT. I'll share my PPT.
Thank you, ma'am. It was a wonderful talk, ma'am. Thank you so much.
Thanks a lot. Thanks a lot.
Yes, participants, our next session will start exact at 2:30. Right? So you should join at the same link that is for the this session. The same link will be there for the evening session also. Right?
Thanks a lot. Have a good day.
Okay, thank you, ma'am. Yes, good afternoon, participants. And good afternoon, Parminder sir.
Good afternoon, madam.
Sir, we will start shortly at exact 2:30.
Okay, no issue, madam. I'm waiting for that.
Yes, good afternoon, participants. So, welcome to the evening session of this short-term course. And this session is about speech synthesis. Speech synthesis is the artificial production of human speech. A computer system used for this purpose is called a speech computer or speech synthesizer and can be implemented in software or hardware products. Speech synthesis has been a vital assistive technology tool, and its application in this area is significant and widespread. It allows environmental barriers to be removed for people with a wide range of disabilities. The longest application has been in the use of screen readers for people with disabilities. Currently, there are many tools created by software providers who have created their own models and algorithms to provide this text to speech as a service. Although text to speech seems very simple in the current technology world, but it has many challenges and involves many linguistic models and algorithms to provide a near 100% accuracy. And today we have with us Dr. Parminder Singh from GNDC Ludhiana, who is going to talk about speech synthesis. It is a great pleasure for me to introduce him in this 5 days short-term course. So Dr. Parminder Singh is professor in the Department of Computer Science and Engineering at GNDC Ludhiana. He is he has done PhD in the field of speech synthesis and has more than 100 publications in this field. He is a member of various societies, and his main researching interesting areas are natural language processing, speech synthesis, and speech recognition. So now I invite Dr. Parminder Singh to just give his talk on this topic. Welcome, sir.
Thank you very much, ma'am, for this nice introduction. Good afternoon, all the participants and coordinators of the course. So I'm going to talk about the speech synthesis technologies and the development of a system that is for the Punjabi language. Let me share my slide. I hope this presentation is visible to all of you.
Yes, sir, it is visible.
Okay, thank you. So, when we talk about the natural language processing, you all know it deals with the development of computerized systems. Those are able to understand languages used by the human beings and interact with the users in the natural way. So the natural way of interaction can be either in the written form or in the spoken form. To develop a system that understands spoken language, we need all the facilities of a written language understander as well as enough additional knowledge to handle noise and ambiguities in the audio signal. So spoken language interaction with the system requires processing of speech. This speech processing needs knowledge about the phonology of the language as well as added information to handle further ambiguities that arise in the speech as well as noise. So this comes under the field of speech recognition. At the higher end, the system also be able to respond in the natural way. The response of the system in the spoken form comes under the field of speech synthesis. So we can define speech synthesis as the artificial generation of speech waveform. This text-to-speech synthesis is the generation of natural sounding artificial speech corresponding to the input text, right? When we are talking about the text-to-speech synthesis. So a text-to-speech synthesizer is a computer-based system that reads the input text aloud. The input text can be from a word processor, it can be from an email, web page, mobile text message, and it should be generate speech intelligently and with high degree of naturalness. So these speech synthesizers must be differentiated from the voice response systems. Those produce speech by concatenating the isolated words or parts of sentences. Like we are having the announcement systems at the railway stations or at the airports. These announcement systems or voice response systems are applicable only to the limited vocabulary and when the sentences are of restricted structure, right? But these speech synthesizers are capable of producing speech corresponding to the unlimited vocabulary, unlimited sentence structures, and for all the words of the language, as being a general text-to-speech synthesizer. So the process of this speech synthesizer or text-to-speech synthesizer can be divided into the different modules. It includes first the input text is passed to the text analysis module, where text normalization, linguistic analysis, and prosodic feature extraction is being carried out. And the tagged text is then passed to the phonetic and prosodic analysis phase, where grapheme to phoneme conversion took place as well as the prosody generation took place. Now these speech waveform parameters are then passed to the speech synthesis component, where the generation of the speech waveform is being taken place and modification of the speech waveform is being done here under the speech synthesis module to produce the output synthesized speech. Now talking about these different modules of this text-to-speech synthesizer, we are in first the text analysis phase. For producing intelligent and natural sounding synthetic speech, sufficient contextual information must be extracted from the input text. So this text analysis includes text normalization that involves resolving various ambiguities present in the input text, expansion of the abbreviations, numerals, and special symbols, non-word characters like paragraph markers, citation marks, headings, punctuation symbols, etc. are interpreted accordingly. Under the text normalization and under linguistic analysis, it involves the morphological and contextual analysis. So under the extraction of prosodic features from the textual information regarding the phrasing, stress at the word and the sentence level for assigning correct prosody to the synthetic speech is being taken out from the textual information in order to give the proper rhythm, or you can say prosody, to the output speech. So this information is extracted from the input text under the text analysis phase. Now this tagged text is passed to the phonetic and prosodic analysis phase, and this module carries out the grapheme to phoneme conversion and prosody generation. So this grapheme to phoneme conversion determines the phonetic transcription of the input text. It involves automatic disambiguation of the phonetic transcription to produce correct tag to generate intelligent speech. So under prosody generation, it assigns fundamental frequency, duration, stress, and intonation to the synthesized speech, and it carries out labeling the pitch contour after the correctly categorizing sentence, duration modeling to facilitate incorporation of other prosodic features like stress, focus, and emphasis, stress marking at the speech segment level, as well as the intonation marking to control rhythm of the utterance at the sentence level. So this prosody generation is giving the rhythm to the output speech, and these parameters are passed to the speech synthesis phase that is responsible for producing the ultimate synthetic speech based on the information regarding contextual, syntactic, phonetic, and prosodic features extracted from the input text. So then the generation of speech waveform is accomplished mainly with the two techniques. Those are the synthesis by rule and synthesis by concatenation. And the waveform modification is performed with the digital signal processing techniques. Those involves the duration or pitch modification, alteration of the prosodic features, incorporating the emotions to the synthesized speech or to the speech signal. So these three phases are being taken into consideration when we are generating speech from the text. Now talking about the different speech synthesis techniques. These speech synthesis techniques can be broadly classified into system models and signal models. System model are the techniques, those are modeling basically the natural human voice producing organs, right? So here we are trying to model the voice producing organs of the human beings for generating the artificial speech, and under this we are having the articulatory synthesis. And under the signal models, here only the speech signals are modeled, or the frequencies of the speech signal are modeled, or we are trying to generate the speech signal frequencies, right? And under this we're having the format synthesis as well as the concatenative synthesis. So talking about the articulatory synthesis, this approach is based on modeling the human voice producing organs involving the models of the articulators and the vocal tract. These articulatory control parameters used are basically lip aperture, tongue tip height, tongue tip position, tongue shape, etc. And theoretically, it seems the most promising for producing good quality speech, as it is directly simulating the natural human speech producing organs, right? But when we are talking practically, its implementation is much complex because it is difficult to find control parameters from the specifications of the natural organs. Data derived from X-ray analysis is usually 2D, whereas the real vocal tract is naturally 3D. It is very difficult to optimize due to the unavailability of the sufficient data and computational load for taking into consideration of the different parameters those are involved for producing the actual human voice. That will be too much large, and for the real world real-time generation of the speech, the computation load may be very high for producing the real-time speech. So articulatory speech synthesis speech is not gained that much popularity, and not much success has been attained under this particular technique. The second one is the formant synthesis. This method synthesizes only the formant frequencies of the human speech. What are these formant frequencies? Formant frequencies are basically the characteristic frequencies of the human voice. Those are distinguishable from each other. And based on these formant frequencies, we're having the alphabet of a particular language, right? And if we are saying that we're having these many alphabets in a particular language, that means those many distinguishable frequencies of human voice are there in that particular language, right? So here, instead of modeling any physical speech producing organ, we're only try to synthesize the formant frequencies of the human speech. So it uses a sound source for initializing the excitation signal and a vocal tract filter producing resonances similar to the formats of the human speech sounds. So each formant is modeled with a two-pole variable frequency resonator, which enables both formant frequency and its bandwidth to be specified. So formant synthesizers are generally controlled by the rules. Those compute resonant frequencies of the vocal tract or the formants, determine other parameters required to synthesize desired utterance, and are used with specifications of the phonemes of the desired utterance. Right, so this formant synthesis technique has achieved success for producing the artificial sound, producing the artificial frequencies of the human sound. The third one under the signal models is the concatenative speech synthesis. So concatenative speech synthesis technique is based on the concatenating and manipulating the pre-recorded natural speech units to generate the desired utterance. It produces intelligent and natural sounding speech because of relatively less complexity in its implementation and the availability of the control information. So it is capable of producing realistic co-articulation effects if the choice of speech segment is correct. Here, the speech synthesis process has mainly three stages. We can have the speech unit selection, concatenation of the speech units, and speech signal generation and modification. Now here, the important thing is that of the choice of the speech unit that we are going to concatenate. So the correct speech unit selection is usually a trade-off between the longer and the shorter units. Using the longer units, it results in high naturalness, less concatenation points, and good control of co-articulation. So for example, if we are going to generate the speech using the words of a particular language, and if we are storing the words or recording the words of a language, and we are going to concatenate the words of the language to produce the artificial sound. But you see, when we are using the words as the speech unit, in case of concatenated speech, the size of the unit is much larger, so less concatenation points will be there, and the co-articulation that is required under a speech synthesis system, that is being preserved within the unit itself. But the disadvantage is that the amount of required units and the memory will be large, right? Because it is very, you can say, not possible in human to store each and every word of a particular language, and even we are using the words of the other languages also in a particular language. For example, if you are talking about the Hindi or Punjabi language, we are using the many words of the English language in our daily life. So storing each and every word of a particular language in the database is not possible. And even if you're going to store much of the words of a particular language, the size of the database will be much large. And on the other end, if you are selecting the shorter units, it will result in small number of units required and hence less memory requirement. These are the advantages. But the sample collection and labeling procedures require more difficult and complex. So if we are using the smaller units, for example, if we are using the phonemes, phoneme is the smallest unit of a particular language that has its own, you can say, importance. So if we are going to store phonemes of a particular language, the advantage will be that we'll be having the very less number of speech units, but the concatenations required for generating a particular speech segment will be much more, and even storing those particular phonemes of a particular language will be very much difficult. Marking those phonemes or labeling those phonemes in a recording will be very much difficult, right? So we may not be having the good quality of the phonemes to be stored in the database, right? So a good balance between quality and size of the units is quite difficult to maintain in case of the concatenative speech synthesis system. So when we are talking about the different speech units, the following choices can be there for the speech units. One is the word, as I have already discussed. So if we talk about the advantage for this is that we preserve the within unit co-articulation effects. Being longer, it results in less concatenation points. However, the disadvantage is that recording and storage of very large number of words is required, and problem arises for synthesizing names, foreign or the new words. And the second choice of unit can be the phonemes. As I have already talked, this is the smallest unit of speech, and usually a language has only 40 to 50 phonemes in general. So we need to store only the 40 to 50 phonemes for a particular language for the generation of any sound, and it gives the maximum flexibility. But the problem is that in the extraction of the phoneme sounds from the recorded sound, and large number of concatenation point results in the low smoothness, or you can say less naturalness of the output speech. Other choices for the units can be that of the diphones. It roughly has the last half of the one phone followed by the first half of the next one. When we are talking about the diphone, that means di means two and phone means phonemes, right? So we are having the two phonemes here in a single unit. Here we are having the last half of first phoneme followed by the first half of the second one, right? So this preserves the basically transition between the phones, right? For example, if you're talking about my name Parminder, then we'll be having the different phonemes per, r, min, the, r. So these will be the different phones or phonemes of this particular sound segment Parminder. So if we see here, we are preserving the transition from one phoneme to another phoneme, right? We are basically preserving the co-articulation of the transition. Boundaries between diphones occurs in the middle of the phoneme that is considered to be the most stable part of the phoneme. However, the limitation is that in the extraction of the diphone sounds from the recorded sound, so it is very much difficult to extract the diphone sound from the recording, and the limitation is second one is that of the less naturalness of the output speech. So with the diphones, we are not able to gain that much naturalness as is required for a TTS system. The next choice of the speech unit can be the syllable. So these syllables are made up of two or more phonemes and in turn makes the words. So it preserves the within unit co-articulation effects. So these syllables are basically larger than the phonemes, smaller than the words, right? And being larger than the phonemes, it preserves the within unit co-articulation effects, and being longer than phonemes, it results in less concatenation points and hence more smoothness. The total number of syllables required are very less than the words and hence less storage requirements. Any name, foreign or new word can be formed from the corresponding syllables. However, the limitation is that between two syllables, co-articulation is not necessarily weaker. So wherever there is a change in from one phoneme to another, from one syllable to another syllable, so that transition phase may not be that weaker, and so it will result in disturbance at that particular point. So syllable basically, if we talk about my name Parminder, so we will be having the 3 syllables per minder, right? So if you talk about the transition from per to min, the first syllable to the second syllable, so the transition from one syllable to another syllable, second syllable, may not be that much weak, and it will result in the disturbance at that particular transition period, right? So with syllables, good quality of speech can be synthesized as the speech unit, and the next choice for speech unit can be the demi-syllables. So it represents the initial and the final part of the syllables, right? As it is, the name indicates demi-syllable. So the initial and the final parts are the syllables, and approximately 1000 demi-syllables are needed for the 10,000 syllables. So you can see the reduction in the database for a particular TTS system if you are using the demi-syllables as the speech units, and most co-articulation effects are taken into account when we are taking demi-syllables as the speech units. But the limitation is that all possible words cannot be synthesized at least the proper names with the use of the demi-syllables, and naturalness of the output speech is less than that with the syllables, right? So with the concatenative speech synthesis system, we can be having the different speech units as the choice to be concatenating for producing the output speech. That can be the words, that can be the phonemes, that can be your syllables, diphonemes or demi-syllables, right? So these are the basic 3 techniques. Those are being used for the speech synthesis. Now I'm going to next discuss the development of Punjabi TTS system that has been developed based on the concatenative speech synthesis technique and using syllables as the basic speech units. So before discussing about the different modules of this TTS system, let me first introduce, give you introduction about the Punjabi phonology, so that the listeners, those are not aware about the Punjabi language, can be get glimpses of the different aspects of the Punjabi language. So it will be easy to go through the different modules of this TTS system. So phoneme is the minimum speech unit of a language by which the meaning may be differentiated. Phonemes of Punjabi language can be classified into the segmental and the supra-segmental categories, as is shown in the figure. So under segmental phonemes, we are having the vowels and the consonant. Those are discrete and distinctive. And under the supra-segmental category, those are having the stress, nasality, juncture, tone, and intonation. And these supra-segmental phonemes are having the dependence on the segmental phonemes and have presence over more than one segment, right? So Punjabi language has 38 consonants and 10 nasal and 10 non-nasal vowels. Vowels can appear alone in the orthography, however consonants can appear along with the vowels only. And the second vowel, that is the shvo, represented by ada, are represented diacritically. All other vowels are represented diacritically. However, this vowel, that is the second one, ada or shvo, this is not being represented diacritically in the text, right? So other vowels except this one are being represented diacritically along with the consonants in the written text. So the different modules for this TTS system for Punjabi are involving text pre-processing, short deletion in Punjabi, syllablification of Punjabi words, preparation of Punjabi speech database that includes selection of Punjabi syllables, recording of sentences, marking of syllable sounds, and generation of the concatenated speech waveform. So under the pre-processing of the input text, we involve the resolving of the different textual ambiguities that may be there in the written text. So these ambiguities may be present in the input text. Those must be resolved for producing the intelligent speech. So for example, expansion of the numeric values, like we may be having the numeric figure 1947, and if this 1947 is a year, then it will be pronounced as 1947 or 1947, right? However, if it is a currency amount, then it will be pronounced as 1947 or in Punjabi 1947, right? So for our system to be intelligent one, this figure 1947 must be pronounced correctly. If it is a year, it will be pronounced as 1947, and if it is a currency amount, then it should be pronounced as 1947, right? Second one is the expansion of the abbreviations. So the abbreviations must be expanded correctly. For example, in Punjabi, this pro can be the abbreviation for the professor or the proprietor. For example, in case of English, that dear dot is most commonly being used for your doctor, or in some of the computer literature books, it can be used for the drive, right? St dot can be used for the saint, or it can be used for the street if it is an address. We can be having the special symbols in the text. For example, 5/6, it can be used as for example, short form of the date, for example, 5th June, or if it is in the, for example, certain mathematical expression, then this can be representing a division, 5/6. Similarly, 7/8, it can be, for example, if it is a score of some game, it can be pronounced as 7/8, or if it is in the mathematical expression, then it is a 7-8. So these ambiguities must be resolved correctly to produce the intelligent speech. So for the development of this Punjabi TTS system, these ambiguities are resolved based on the contextual information about the ambiguous entity in the text. So in order to resolve such ambiguities, what we have to consider the context in which that particular ambiguous entity is there, right? So based on the context, we will resolve that particular ambiguity, right? The surrounding words will give us the indication about the correct, you can say, for disambiguating that particular ambiguous entity, right? Further one is the expansion of the abbreviations. So Punjabi abbreviations are expanded to the full word form as these will be spoken. So abbreviations are processed in 3 ways. For example, we may be having the abbreviations with the dot after the initial word. These are expanded to the full word form. For example, we are having the people, those can understand the Punjabi. We are having the P dot, Punjab dot, for example, Ra dot, Babin Siari dot, this fourth one dot. So this will be expanded as Punjab Raj Billy Board. So these abbreviated particular letters are expanded to the full words, right? And if the expansion is not available for that particular abbreviation, so these are spoken letter by letter, right? Similarly, there may be the abbreviations without dot. For example, we are having the particular abbreviations, for example, BJP, UPA, or NASA. So these abbreviations are mostly being used without the dot. So these are being spoken out as a single word, for example, Bhajpa or NASA, right? So most of the abbreviations in Punjabi are included for the expansion of the full word form. Then we are having the orthographic transformations. So certain consonant vowel sequences are spoken differently from their orthographic representation by the native speaker. So for example, we are having the different words. For example, Sheher. So this word Sheher is not being pronounced in the same way as it is being written, right? So these words are being transformed to the form it is being pronounced in the native language. So for example, we have devised the different rules for such transformations. We are replacing the combination of these two characters, the consonant haha and the second one is the vowel, represented by this in the orthography by attaching the vowel, this one, to the previous consonant, So this particular character or consonant in the word sheher is being replaced by this one in the transformed word. Similarly for the word neher. So again, we are replacing the combination of these two, the consonant and the vowel in the word with the preceding consonant plus the vowel, this one. For example, we are having this consonant plus vowel combination in the particular word, and this is being replaced by this one, replacing the vowel, this one, with this one attaching with the preceding consonant. So if the consonant preceding to the character, the consonant haha is having the attached vowel, this one, then it is replaced this vowel with the this one, right? So we are having, for example, this one. Here we are having the vowel attached syari to the previous consonant to that of haha, that is being replaced by this lam to the previous consonant. So if the consonant proceeding to the character haha is having the attached vowel, this one, anchored, then replace this vowel with this particular vowel to that of the attached particular consonant. For example, here in this word, to the consonant proceeding to this second one, we are having the attached anchored vowel, then that is being replaced with this one in the transformed particular word. So such type of orthographic transformations are to be taken into consideration in order to transform the words to the form those will be actually pronounced while producing the synthesized speech. So certain words, those are not to be pronounced as such as in the written form, are to be transformed to the form in which those are being spoken by the native speaker. So then is the expansion of the numeric numbers. So as you know, the numeric numbers present in the input text are spoken in the expanded form. So these are expanded to the full word form. So up to 19 digits are being taken into consideration to expand the numeric figures to the full word form, right? So then is the important aspect in case of the written text, that is the schwa, presence of schwa, and this schwa is to be deleted in some cases, and the same is being taken place in case of the Punjabi language. So what is first the schwa? Schwa is the mid-central vowel that occurs in the unstressed syllables, right? So phonetically, it is very short, neutral vowel sound. Like all vowels, its precise quality varies depending upon its adjacent consonant, right? In Punjabi, the second alphabet of the Gurmukhi script, that is Eda, is the schwa. So other vowels except this schwa are explicitly written diacritically around the consonant, right? However, this schwa is not being written in the orthographic of the Punjabi text. So consonant represented in orthography without any attached diacritic have the associated inherent schwa vowel. So whatever consonant is there, we have seen that the consonant cannot exist in the text without any vowel. So wherever there is no diacritic sign along with the consonant, we mean that, or we understand that there is the attached inherent schwa vowel with that particular consonant if there is no other diacritic sign. So In Punjabi, like many other languages, schwa is sometimes pronounced and sometimes not, depending upon certain morphological factors. So this is important here when we are producing the output speech corresponding to the input text, that where we have to keep this schwa silent and where the sound of a schwa should be there in order to produce the correct output speech, right? So thus, schwa does not always emerge in the word's pronunciation. Existence of schwa vowel in a word makes the task of determining its correct pronunciation more complex, right? So if there is the existence of a schwa in a particular word, so we have to see whether the sound of that schwa should be there for the correct pronunciation, or the sound of schwa should not be there for the correct pronunciation of the word. So, schwa deletion is a phonological phenomenon where schwa is absent in the pronunciation of a particular word, although ideally it should have been pronounced. So, for accurate pronunciation of words, it is necessary to identify which schwa is to be deleted and which is to be retained. For example, in case of the word this doctor written in Punjabi, we are having the attached vowel. This capital C represents the consonant, and this small v represents the diacritic sign of a particular vowel, and this capital S represents the schwa in the particular word, right? So if you see, we are having the pattern of this C, V, and S. And we're having the two schwas here, for a particular three schwa here, after the second consonant, after the third consonant, and after the fourth consonant, right? If you go for the pronunciation of the word doctor, then you can see that after the word k, after the particular letter k, there is a break in the pronunciation, doctor, right? And this break basically represents the absence of the pronunciation of the schwa, right? So this schwa that is after the k sound is not to be there for the correct pronunciation of that particular word. And as well as the grammatical rule, the schwa at the word end is to be dropped, right? So the schwa that is at the end of the word after the fourth consonant is to be dropped as per the grammatical rule. So we have to drop these two schwa, that is after the second consonant and after the word end. However, if you see the presence of the schwa after the third consonant, then we are having the pronunciation of ter. We are having the pronunciation of ter, doctor. And if you see the pronunciation of the second syllable, ter, it shows the existence of the sound in between ter and r sound, right? So that basically gives us the idea of the presence of this schwa in the pronunciation of this particular word, right? In the pronunciation of this particular word. So if you see this schwa after the third consonant is to be preserved or to be retained. However, the schwa after the k particular consonant and at the word end are to be dropped or are to be deleted, right? So in this way, an algorithm has been developed for this schwa deletion for the Punjabi language. And here this table basically represents the output of this schwa deletion algorithm. This is the input Punjabi word, and this is the consonant vowel pattern of the input word, right? And these are the, for example, the output consonant vowel schwa representation of the that particular word. For example, here in this case of particular word kharbuja, we're having the schwa after the first consonant khar, and if you pronounce it khar, then there is the sound of after the first consonant. However, the sound of after the second consonant is not there, and that sound is to be dropped there. There is a break after the R sound. So this second schwa is to be dropped from the pronunciation of this particular word. So if you see the consonant vowel pattern of this particular input word, this second schwa has been dropped, however the first schwa has been preserved. So in this way, the output of this particular input words are being obtained from the schwa deletion algorithm. So if we are talking about the performance evaluation of this algorithm, the performance of the proposed algorithm is evaluated on 10,000 most frequently used words in Punjabi. So these words are selected from the Punjabi corpus that consists of more than 104 million words in total and more than 23 lakh unique words. And the output of the algorithm of these words has been checked manually. And out of these 10,000 words, 144 are found with wrong schwa deletion and giving the accuracy of the algorithm as 98.56. And the maximum number of words, that is 6.56, with wrong schwa deletion are having length of 6 characters, and words having length of 2 characters are having no schwa deletion, right? So this is the, you can say, the conclusion or the output of this particular algorithm. So most of the words for which algorithm is producing wrong results are those consisting of the gemination in Punjabi, that is the presence of adak in case of Punjabi words. So having consonant clusters means existence of 2 or more consonants in a single form, in a single word. So these consonant clusters in which one consonant appears below the barrier consonant. So these consonant clusters are existing in Punjabi as the peri-akshar, right? So some letters are being represented as the, you can say, subscript, or as the, in the, below the bearer consonant. So formed with a combination of 2 words like the Vidhan Sabha, Mahatmapuran or Pradarshan are also producing the wrong, you can say, results in case of the schwa deletion algorithm. Now the next is the syllabilification of the Punjabi words. So because we are using the syllables as the basic concatenation unit for producing the output speech or the synthesized speech, so we need to syllabify the words of the input text into the different syllables. So before coming to the syllabification, let's discuss first what is the syllable. So syllable is the basically a combination of phonemes that gives the next higher unit called the syllable. So which is one of the significant unit of a language. So it is the part of the speech sound between the 2 pauses. It is a part of the speech sound between the 2 pauses. Syllables further combine to produce larger units like morphemes or words. So it is the unit of speech sound that is potentially larger than phoneme but smaller than the word. So specific sequences of phonemes are important in different languages and establish different syllable types in a specified language. Presence of vowel is obligatory for formation of a syllable. So for a particular syllable, the existence of vowel is compulsory or mandatory, without which a syllable cannot exist. A syllable with multiple phonemes will always have a vowel and other phonemes being the consonants. So if we are having more than one phoneme in a particular syllable, then that one must be the vowel and others can be the consonants. Others can be the your consonants. So moving further, so I have seen right now that one participant has given don't know Punjabi. Okay, sir. I will try to explain it other way around. So in syllables, particularly if we talk about the Punjabi syllables, the recognized patterns and hence the types of syllables are shown in the table below, where C and V represents the particular consonant and vowel, right? C is for consonant and capital V is for the full vowel. So the different patterns of consonant and vowel, those are being recognized in the Punjabi. Those are the only single vowel. Vowel consonant. These are the examples given in Punjabi for those particular syllable types. Then we can have the consonant vowel. Then we can have the vowel consonant consonant. Then we can have the consonant vowel consonant. We can have the consonant vowel consonant consonant. And we can have the consonant consonant vowel consonant. Right? So these 7 type of syllables are being recognized in the particular Punjabi language, and similarly for the other languages, the different patterns of consonant vowels are being recognized, and those becomes the types of syllables in that particular language. For example, the word formation in Punjabi, if we are combining this CV pattern with again the CV pattern, we are having consonant joined with the vowel. Again, in case of consonant joined with the vowel, and third one syllable is being the consonant vowel consonant, and we are getting this particular word with a combination of the 3 syllables. With a combination of 3 syllables. Okay, Mr. Swapnesh, I'm reading your message that you're knowing the Bengali. So basically, I was discussing about the development of this particular Punjabi TTS system, and sorry, I was not aware about this fact that the participants will not be aware about the Punjabi language. So basically, I will be concentrating more on the procedure than that of the particular examples of the Punjabi language. Right? So for the development of this Punjabi TTS system, Punjabi syllables of the first 6 types are these. First one, vowel only, vowel consonant, consonant vowel, vowel consonant consonant, and consonant vowel consonant, as well as the consonant vowel consonant consonant are considered for the development of this Punjabi language. And the last one, we have dropped this choice in order to reduce the database size, because the syllable type consonant consonant vowel consonant is not taken into consideration because its existence of you can see very less existence in the Punjabi language, right? So we may drop one of the syllable type if its existence is less in the language. So on the same lines, we have considered only the first 6 type of syllables in the Punjabi language to be considered for the development of this TTS system. So talking about the syllabification, dividing the text into different syllables. So this process of syllabification is the segmenting a word into its constituent syllables, right? So segmenting a word and recognize its syllables, it is not a simple task. One has to follow the phonetactic constraints of the language for the syllabification. So these syllabification rules are mostly language specific. So although for the computation purpose, syllabification process is carried out on the orthographic form of the input text, it is in fact a phonological phenomena that takes place during the pronunciation of this text. So native speakers do not syllabify words in a way that violate the phonetic constraints of that particular language, right? So syllabification rules, those are specific to a particular language, are to be taken into consideration for segmenting a particular word into the different syllables, right? So segmenting a word into syllables is a challenging task. So an algorithm for syllabification of Punjabi words has been developed. The syllable structure in Punjabi and grammatical constraints are taken into consideration for formulating the syllabification criteria. The output of this proposed algorithm is evaluated for its accuracy on the first 10,000 most frequently occurring words of the Punjabi, right? So these words are selected from the Punjabi corpus, as we have taken earlier in case of short deletion for checking purpose, from the corpus having 104 million total Punjabi words and more than 23 lakhs unique words. So these words are first syllabified with this algorithm, and these are then checked manually for their accuracy. And here are certain examples of the syllabification output of this algorithm. So we can see, for the persons those are not aware about the Punjabi language, you can only see the this second column that is giving the consonant vowel pattern of the input word, and this last column is giving the syllabification of those particular words into the different syllables, and these are giving the syllable types. And those are aware about the Punjabi language, this is the word, for example, aya, that is consisting of 3 full vowels, and these full vowels has been segmented into the 3 syllables. Those are all the vowels. For example, we are having the word second one, England. So this word England has been syllabified into the 2 syllables, dividing the words at the middle, ing and land, and thus giving us the particular syllable type of this N is being used for the nasality, and that means full vowel with nasal sound, right, and the consonant. And similarly, this particular syllable is having a small v and N, that means the diacritic sign of the vowel and not the full vowel, and again N is representing the nasal sound, right? So we have to use the representation capital V for the full vowel, and if the existence of the full vowel is there, for example this one, and as I have already mentioned that in case the vowel is coming with the consonant, then the diacritic sign of that vowel will be represented with that particular consonant, right? So here this small v and this N is representing basically the diacritic sign of that particular vowel, and that is nasal. Similarly, we are having the other examples and the corresponding consonant vowel pattern and the corresponding segmentation of that particular word into the different syllables, right? So talking about the performance evaluation of this algorithm, so maximum of 4.70 words having 3 syllables are wrongly syllabified, whereas minimum of 2.11 disyllabic words are syllabified incorrectly, giving maximum syllabification accuracy of 97.89, right? So some of the wrongly syllabified words are given here for the example purpose, because we got the words wrongly syllabified because the pattern of these words is same as that of the other words. Those are correctly syllabified, but the pronunciation of these words require the break at the other intervals than that of the required for the correctly syllabified words, right? So when we syllabify the words, those are having the same patterns, then we will be having the wrong syllabification. For some of the words, those are having different pauses of pronunciation when we are pronunciation the word. So these words, different pauses required for the pronunciation from the other words of Punjabi having similar syntactic structure. Syntactic structure means the consonant vowel structure. So the overall accuracy of this algorithm is evaluated to be 97.65. So next, coming to the preparation of Punjabi speech database. So speech database is a core component of a concatenative TTS system and influences the quality of the output speech signal. The quality of the output synthesized speech signal depends upon how accurately speech database is prepared. So the two main factors affect the quality of the speech database. One is the selection of the speech unit, which controls the naturalness of the output speech signal. And second one is the number of speech units to be stored in the database, which affects the database size and has the response time and portability of the TTS system. So now these days, we require the TTS systems, those are portable and to be installed on the portable devices. So we require the overall size of the system should be very small, right? And hence the size of the database should be less. So Punjabi is a syllabic language, and so syllable is selected as the basic speech unit to be stored in the database. So further, for limiting the number of syllables in the database, the frequency of occurrence of the Punjabi syllables in the Punjabi corpus is found to select the syllables for the speech database. So it is not possible to store each and every syllable of the Punjabi language in the database. So for that purpose, what we have done, we have basically gone for the finding the frequency of occurrence of the syllables in the corpus, right? So depending upon that frequency of occurrence, we have selected the syllables based on their occurrence in the Punjabi language. So theoretical count of Punjabi syllables, if we go for the 35 consonants and 10 nasal and 10 non-nasal vowels, and we are considering these first 6 type of syllables, then with the syllables with non-nasal, you can see 38 consonants and 10 nasal and 10 non-nasal. We will be having this number of syllables with non-nasal vowels corresponding to these syllable types, and the same number of syllables with the nasal vowels corresponding to these syllable types, right? And in total, we're having this much more than 11 lakh Punjabi syllables theoretically, right? However, out of this theoretical count, some of the syllables or some of the vowel consonant combinations may not occur in the Punjabi language. So in order to check that, we have checked these syllables on the Punjabi corpus. So for that purpose, statistical analysis of Punjabi syllables is done to select an optimal set of Punjabi syllables out of the total more than 11 lakh Punjabi syllables. It is essential to analyze the use of these syllables in the language. For this purpose, statistical analysis has been done on the Punjabi corpus, and for that purpose, again the same corpus is being used, that is having more than 104 million Punjabi total words and more than 23 lakh unique words. The frequency of occurrence of total available syllables is found in this corpus, and based on the frequency of occurrence, the set of Punjabi syllables is selected for storage in the database. So this is the finding of this statistical analysis. If you see, for the non-nasal and nasal syllables, So we are having the non-nasal syllables with the frequency of occurrence more than 0, this much corresponding to each syllable type, and similarly for the nasal syllables, this count corresponding to each syllable type, right? So you can see in total these much syllables are the valid Punjabi syllables as per their existence is concerned, as found in that much large corpus. If a syllable is not occurring in such a large corpus, then there are the chances that that syllable will not be existing in the Punjabi language, right? And from this statistical analysis, you can see the total count has been reduced to only 24,000 syllables out of the total more than 11 lakh total syllables, right? So we are now considering only the 24,000 Punjabi syllables. Those are valid and have their existence in the Punjabi corpus. So during the in order to see the occurrence of the Punjabi syllables in a particular word, we have to see the position of that particular syllable that is occurring in a particular word. So during the utterance, stress, duration, and articulation of the same syllable is different at the starting, middle, and end position of a word, right? So for example, the sound of the syllable, for example, C, we are having a syllable C, right? That is of type consonant vowel, is different when it is occurring in the starting of a word, for example, in the word sita, in the middle of the word, for example, masita, and in the end of the word, for example, kursi, as well as when it is occurring as a monosyllabic word, for example, the only word C. So it means that when a particular syllable is occurring at the starting of a particular word, or at the middle of a particular word, or at the end of a particular word, or as a monosyllabic word, its sound is different, right? For example, when it is occurring at the starting of a particular word, more stress is on its particular syllable. However, when it is occurring in the middle, less stress is there, and when it is occurring at the end of the word, even more less stress is there on that particular syllable. And hence, for high quality TTS system, syllable sounds needs to be stored separately for these three positions if exists, as well as for the monosyllabic word. So if we are requiring high quality speech synthesis system, so these sounds for these syllables should be stored separately for the starting, middle, end positions, as well as for the monosyllabic words. So the frequency of occurrence of the syllables at the starting, middle, and end position is found separately for the nasal and non-nasal syllables. And here is the finding of this analysis. You can see in that particular corpus for these syllable types, these are the occurrences of the syllable types as a monosyllabic word, as a syllable in the starting position, in the middle position, or in the end position, right? And this is the total frequency of occurrence of these syllables at these occurrences, right? So frequency of occurrence at the starting, middle, and end position for the nasal syllables, as well as for the non-nasal syllables, has been calculated separately, and we have found that the occurrence of non-nasal syllables at the starting position of words is more than the middle and end position, or as a monosyllabic words. And second is, nasal syllables occur more at the end position of a word than at the starting and middle position, or as a monosyllabic word. And syllables occurring at the middle position of words are less than at the starting and end positions, as well as the monosyllabic words, as shown in the figure. right? So this is the basically finding of this analysis. Occurrence as a monosyllabic word is more than that of the other positions. Then is the selection of final syllable set for the speech database. So as I have discussed, only the valid 24,000 syllables out of the total are being selected, having the frequency of occurrence more than 0. So out of these 24,000 syllables, we have selected only the first 10,000 most frequent occurring syllables having cumulative frequency of occurrence less than 99.81, right? So only the syllables having frequency of occurrence less than 8 are ignored or omitted, right? So you can imagine if a syllable is not occurring in such a large corpus for not more than 8 times, that means the existence of that syllable is very less, right? So that's why we are ignoring those syllables and selecting only the first 10,000 most frequently occurring syllables. So with these many syllables, TTS system will be able to cover almost all Punjabi words, generate word borrowed from the other languages, as well as pronounce names of the persons as the nouns, and hence produce speech database for a general TTS system for the Punjabi language. So for these 10,000 finely selected syllables, sounds are to be stored for the starting, middle, and end positions in the word, as well as the monosyllabic words. So this produces theoretically 40,000 occurrences of the finely selected syllables, because for each syllable out of these 10,000, 4 different positions are to be stored. But not all syllables may exist in all of these 4 positions. So statistical analysis of these 10,000 syllables reveal that their positional occurrence in the words in the corpus is as such, right? So this is at the starting position, middle position, end position, or as a monosyllabic word. So results produce that total 24,688 syllables are to be stored in the speech database for the Punjabi speech TTS. So out of these 40,000, only 24,000 are the syllables. Those are existing in the different 4 positions in the words as is analyzed on that particular corpus, and only these 24,000 syllables are selected to be stored for the Punjabi TTS system. So in addition to this, to store the gemination sounds of the Punjabi, consonants with adak or this symbol characters are analyzed for their occurrence in the corpus, and we have found that 375 gemination sequences exist in the corpus, right, out of the total 760, and these 375 gemination sequences are selected for storage in the database. And further, to increase the naturalness of the synthesized speech, sounds of first 1,000 most frequently occurring words from the corpus are stored in the database, right? So sound of these words will be used directly for concatenation in the output generated speech waveform, right? So in order to increase the naturalness, we have selected the first 1,000 most frequently used words. Those are to be stored directly in the database so that these can be used as such for the synthesized speech in order to increase the naturalness. Then is the recording of these particular syllables. So the sounds of Punjabi syllables finally selected for speech database must be natural enough so that speech produced by the concatenation of these segments is of high quality. To achieve this, it is decided to collect the syllable sounds from the recording of the sentences rather than the words. So in order to increase the naturalness of the output speech, if we are marking or labeling the syllables in the recorded sentences, that will be having more naturalness than labeling those syllables in the recorded words. So choice of sentences over the words is quite obvious because duration of words spoken in sentences is less as the sounds more natural than those spoken in isolation. Sound of a syllable as a part of sentence preserves better and real-time articulation that accounts for high-quality synthesized speech. So despite of the fact that large amount of recording is required if we are selecting sentences to be recorded than that of the words, but for the naturalness of the database or the synthesized speech, we have to record the sentences and we have to label the syllables on those sentences. So selection of sentences for the recording. To select sentences containing selected syllables for the speech database, Punjabi corpus having more than 4 lakh sentences in total is used. So out of these, more than 3 lakh sentences having length less than 50 words are selected, eliminating the large sentences to avoid the prosody, lack of prosody, as well as discomfort for the recording. To reduce the recording time and hence the size of the recorded sound file, efforts are made to select minimum number of sentences out of these selected. Those are covering all of the selected syllables as well as the first 1000 words. So an algorithm based on the set covering problem is developed for this purpose for selecting the minimum number of sentences. Those are covering those selected syllables, and this algorithm selected 9,214 sentences for the recording purpose. Those cover all of the selected 24,688 syllables to be included in the database for the recording purpose. So recording of these sentences is done by a professional female speaker, and these are the properties of the sound file that was kept for the recording purpose, and this gives us recording of about 28 hours. So then is the syllable sound labeling. The syllable sounds are marked in the recorded sound file for their starting and end positions that are further stored in the database. So labeling of syllable sounds in the recorded sound file is an important and time-consuming task. However, it needs to be accomplished with carefully because the quality of final output speech depends upon how accurately the syllable sound boundaries are marked. Not all constituent words of the recorded sentences contain syllable from selected syllable set. However, these are recorded as part of the sentence to maintain its intonation. So also, some words may be included in already selected sentences. So such words are identified as extra or unwanted, and their sounds are deleted to reduce the size of the recorded sound file before starting the labeling of the syllables. So after deleting these extra or unwanted words, we got the final recording of 7 hours and 15 minutes. So for syllable labeling, we have used the Sonic Foundry SoundForge software for the marking purpose, and this is how we have marked the particular syllable in that particular recorded sound file, storing the starting and end positions of the that particular syllable. So as boundaries are marked manually, so before finalizing a boundary position, one must be sure that it is not being marked at a point such that syllable is heard with abrupt sound change at the boundary. So some difficulties are encountered during labeling of syllables in a recorded sound file because two syllables within a word are sometimes overlapped to some extent at the boundaries, and labeling a short duration syllable is also problematic. In some cases, such syllables may not produce quality output sound while concatenated with other syllables to generate the word sound. In natural utterance, the changeover zone between two adjoining syllables of a word is significant to sustain continuity in the speech. So this reason that preserves the articulation at joining point is difficult to be reproduced while concatenating the two syllable sounds. So this is the simple database design for storing the syllable positions. So then coming to the generation of the concatenated speech, the speech corresponding to the input text is generated word by word, which is further concatenated to produce the sentence sounds. So each word is first searched in the database. That may be among the most frequent 1000 words or monosyllabic words stored in the database. If found, its starting and end position in the recorded sound file are returned from the database. Otherwise, it is passed to the short deletion and syllabification module. And the output of these modules is the syllabified word. To generate the sound of a word, syllable sounds of constituent syllables or the words are to be concatenated. Each syllable is searched in the database for its starting and end position in the recorded sound file and corresponding to its positional occurrence in the word. The speech segment of a syllable or word are extracted from the recorded sound file and are put in the output speech file. Combining speech segments of constituent syllables of a word in output file, concatenated sound of a word is produced. So this process is repeated for all the words of the sentence and further for the sentences of the input text. So thus the corresponding concatenated output sound waveform is produced for the input text. So this process has been explained with the use of this architecture. So first the input text is passed to the text pre-processing module, which resolves the different ambiguities, expansions and numbers to the full word form or transformation of the words. And this particular output, this text pre-processing is passed to the segment text into sentences and further to words. And these words are searched in the database if they are existing as such in the database and it is out of the most frequent words. If it is existing, if it is present, then it returns the starting and end positions from the database. And then extracting the word bytes, word data bytes from the recorded sound file, and these data bytes are combined together to generate the output speech. If this word is not present in the database as such, then it is passed to the short deletion module and further to the syllabification module, and these syllables are then searched in the database, right? If this syllable is present in the database, then its starting and end position is returned from the database, and these corresponding data bytes are being extracted from the recorded sound file, and these are combined together to get the word data bytes, and the output sound file is generated to give the output speech, right? So I have taken here the example of again a Punjabi word, Punjabi sentence to explain this process. I'm sorry for the participants those are not able to understand the Punjabi language at this moment of time. So this particular Punjabi sentence is passed to the first pre-processing module, and as such here the textual ambiguities are resolved to that of this particular word, for example 1947. So this 1947 is first because it is being used as a year here in this particular sentence. So it is being expanded as 1947, right? Further, the abbreviation that is of Pandit is being expanded to its full word form, right? And then the numeric figure 290 is being expanded to the 290, right? By the conversion of the numeric numbers to the full word form. And after that, the orthographic transformations took place for replacing this word Nehru to the word that is being transformed to the corresponding word with certain changes of the attached vowels to the way it will be pronounced by the native speaker. And after that, the short deletion will took place, and this is being represented by the consonant vowel representation of the particular words. Then the short deletion took place, and the output of this short deletion module is passed to the syllabification module as represented here, and we will be getting the syllabified words as represented here and the corresponding consonant vowel pattern represented here, right? And these syllables will be passed to the corresponding module for searching in the database and correspondingly generating the output speech corresponding to these syllables, and these output sounds of these syllables will be concatenated to produce the sounds of the words and further the sounds of the sentences, right? So this was the all about the development of the Punjabi speech synthesis system, and I would
Yes.
like to take all the queries from the participants. This was
Yes.
all about the development of Punjabi TTS system. So I've explained the different modules or different you can say processes those have been adopted for the generation of the Punjabi sound corresponding to the input text. So I would like to have the queries from the participants.
Yes, any query from any participant?
Excuse me, sir.
Yes, yes, Abhinav.
Sir, if suppose different people have a different, different type of sentences they make. Suppose I am making the same sentence. I mean to say that suppose 3 or 4 people mean to say the same thing in a different ways.
Yes, yes,
In textual language. So how it can be handled? Can you please briefly
Yes, yes.
explain?
Yes. See, as I have discussed that if we are having a particular sentence as the input,
Yes,
that
sir.
sentence is first being divided into the words, right?
Yes, sir.
And those words are further divided into the syllables,
Okay, sir.
right? So the formation of the sentence for a particular saying is not important, right? For a particular intent, we may be having the formation of the sentences, the different forms. You are correct, right?
Yes, sir.
But here we are dealing with the syllables of the words, right? So we are
Okay, sir.
dividing the sentence into the different words, and those words are further syllabified into the different syllables of that particular word, right? So we are trying to extract the sound of the syllables, right?
Okay, sir.
We're trying to extract the sound of the syllable from the stored database, right? And those syllable sounds will be concatenated to produce the sound of the particular word,
Yes, sir.
right? And the sounds of those particular words will be joined together to give the sound of the sentence, right? So the formation of the sentence by the combination of the words is immaterial in this particular case.
Okay.
Right?
So
You will be having the different syntactic structure of the word of the sentence, right? But ultimately, the sound of the words is being produced from the concatenation of the sounds of the syllables.
okay, sir. Okay, sir.
Yes.
Thank you, sir. Thank you,
Yes,
sir.
any other query from any other participant?
Hi, sir. Amitoj here. One query. Does this text-to-speech system, the intelligent one, would that be able to read Gurbani also? Because
Good.
like it's Gurbani, like it's
Gurbani text.
slightly, yeah, because it's
Gurbani text,
slightly
yes.
different.
Yes, you see, in case of Gurbani, you are having the attached laga matra in Punjabi we say. You may want to say that the combination of the vowels with the consonants in some different way, right? But because again, when the words will be further syllabified, the Gurbani words will be syllabified into the different syllables. Those will be again the combination of the vowels and the consonants, right? So the output of this TTS system, we have checked for the Gurbani words also. It is going to a, you can say, of good quality. of
Great.
good quality, not to the way we were expecting that it would be not of that much level, but it was of good quality for the Gurbani text also. Because if you see the logic of this particular system, we are dividing the word into the different syllables, and syllables are further the combination of the consonants and the vowels, right? And if we divide the Gurbani text also, that will be again the combination of the consonants and the vowels, right? So the stored syllable sounds are joined together to give the sound of the word, and with this combination of syllables, the quality of the output sound of the Gurbani words is also of good quality.
Great. Thank you, sir.
Yes, Nimrat. Nimrat, do you want to say something? Ask anything? Yes, any other query? Okay.
So, madam, you are mute. Please unmute yourself. Madam, you are present. Yes.
Okay, I forget to just switch on the mic. Thank you, sir, for such an elaborative talk on speech synthesis. Actually, it is mistake at our end that we forget to inform you that the participants are all over from all over the India, and some may not know Punjabi. Anyhow,
It's actually my mistake. Actually, I could not make it the general
no,
one.
sir, it's mistake at our end. So anyhow, you have given a nice presentation and try to explain all the concepts with every possible way. And I think all the participants will be really beneficial from your talk in some or the other way. Once again, thank you, sir, for accepting our invitation to deliver your expertise in this field and be a part of this short-term course. Thank you once again, sir.
Thank you, madam. Thank you very much. And I'm again thankful to the coordinators as well as the administration of your department for giving me the chance to interact with such a nice gathering. Thank you very much.
Thank you, sir.
Thank
So, dear participants, tomorrow's session again will be at 10:30. So you should join at the exact time, that is 1 or 2 minutes before 10:30. Right? Thank you, sir. Thank you, all the participants.
Thank you, ma'am. Is the session concluded for today?
Yes?
Is the session concluded for today?
Yeah.
All right. Thank you, ma'am. Bye-bye. See you tomorrow.
Okay, Mitos. Okay, Parminder sir.
Yes, ma'am.
Yes, now I think once again, thanks for
Thank you very much.
accepting our invitation.
Thank you, ma'am. Thank you very much. It's my
Thank you,
pleasure. Should I leave this
Yes,
meeting
sir.
now? Okay, thank you.
Yes, sir. You can now leave. Yes.
Okay, thank you.
Okay.